Yes, start. Right. So once again, come back. We'll be starting with this important points on multiplied clutches. So what are the points to remember while solving the numericals? First thing is, this we have already discussed. The material has to be considered as C40 steel. Usually you have different C30 steel also they will be considering it, but we'll be trying to consider as C40 steel with sigma Y yield stress as 328.6 megapascals and factor of safety 3, which we have already discussed. So the tau shear stress tau S for the shaft will be 54.76 megapascals. This is the first thing which you need to remember. The second thing is the QA factor will be taken as eta will be equal to 0.75. Now here, try to see here, most important, how do I get the values of D1 and D2? What is D1? D1 is nothing but internal diameter or inner diameter, and D2 is outer diameter. So you have, if you see on the screen, I have D1. Okay. I have D1, okay, internal diameter as well as outer diameter. So here we call this D1. Now what happens is D1 and D2 of the frictional lining. Okay, if you are trying to find this values of D1 and D2, now suppose you get a quadratic equation or cubic equation, and if we are getting more than two values, then select the minimum value for D1 and select the maximum value for D2. That is what exactly it is required. So here, so that this area, whatever the area which you are going to get here, this area, okay, should be more. This area should be more. That is the reason why exactly I will be trying to take it. Okay. So once again, the value of D1 should be always minimum. The value of D2 should be maximum. Now next point which you need to remember is, if there are more number of speeds has been given, the range of speeds 1000 rpm, 2000 rpm, 3000 rpm, you will be selecting the speed, minimum speed. Means at minimum speed the torque will be maximum. So I repeat, at the minimum speed the torque will be maximum. That is what exactly we will be trying to select it. Okay. Now the next one, you have selection of coefficient of friction as well as pressure. If he has not given coefficient of friction and pressure, both the things, if he has not given both the values, mu he is not given in the numerical and pressure he has not given in the numerical, then you will be making use of table 19.7. So in table 19.7 you will be selecting dry friction for single plate clutch, wet friction for multi plate clutch. Okay, and you will be taking, there will be a series of values. Let me say mu is equal to 0.2 to 0.5. Then you will be taking the average of value of mu, as well as the average value of P. If there is only single value, you will be trying to take the same value. But if you have the average, the range, then you will be trying to select the average value. This is the next point which you are supposed to remember while solving it. Next, select uniform wear theory. By default, uniform wear theory, until specified, you will be going for uniform pressure theory. Okay. Next, now if the friction material is not given, select leather as a friction material if he has not specified anywhere. So leather on steel, then go to table number 19.7. After going to table number 19.7, you will be selecting the value of mu and value of P. Once again, it depends on the type of clutch. If it is single plate clutch, you go for dry friction, and if it is multi plate clutch, you will be going for wet friction. That is what exactly will be working. Next, the number of active surfaces, the value of I. The value of I in case of single plate clutch will be always 2, and in case of multi plate clutch it will be greater than 2. This is what exactly will be selecting it. So here, how do I calculate for multi plate clutch? The multi plate clutch, the number of active surfaces is equal to I if we take, and number of frictional discs, okay, or we can say bronze disc, all the things, number of frictional discs on the driver shaft I1 will be equal to I by 2. On the driven shaft I2 will be equal to I by 2 plus 1. Okay, on the driven shaft as well as driver shaft we have, okay, driving shaft and driven, and total number of discs will be equal to I1 plus I2, which we have already discussed in the last class while solving the numericals. And so this is the number of active surfaces, and this is the following equations which will be trying to use it. Okay, in case if you do not have the values of D1 and D2, especially in case of multiplate clutches, you will be encountering, because the major unknown in case of multiplate clutch is I. In case of single plate clutch, you will be asked to find the design the clutch, entire clutch. So in case of single plate clutch, you will be asked to determine D1, D2. But in case of multi-plate clutch, you will be asked to determine the number of active surfaces I. Since I is the major unknown, so we need to have the values of D1 as well as D2 here. Since D1 and D2 is required, will you make use of equations 19.91 and 19.90. Now listen guys, in 19.90, as I have already discussed in the previous classes, here we are trying to take for multi-plate clutch half of the values, the average value of half of the average values which I am trying to take it. Okay, in the data handbook, this value, if you take the average, this will be 3D1, but I want you to correct yourself, so I want this value will be 1.5 times of D1. Okay, and most important now, which I'll be trying to talk about, because based on this only entire problems will be there. Now try to see it. FA, can anyone tell me what is the formula of FA in case of uniform weight theory? FA is equal to
half pi p d1 into d2.
Right. So you will be telling half pi p d1 d2 minus d1. This is the value of FA. If you are calculating FA from this formula, this FA is also called as, actually FA is axial force, but this follows what happened is, unfortunate thing is, there are different textbooks, they started using the different names. It is also called as maximum axial force, or limiting axial force, or required axial force. So remember these terms: maximum, limiting, required axial force. And from this axial force, there is a term called as P. After finding FA from this equation, and if we are trying to find pressure from the same equation, if we are finding the pressure from the same equation, then we call this as maximum or limiting pressure. If we are finding pressure from the same equation, so FA you have determined from this equation. Now pressure he would have given already in the numerical, but still he'll ask us to find the maximum pressure. He'll ask us to find maximum pressure. Then we'll go back to this formula by this equation. Then we'll be trying to find once again pressure from this equation. Then this pressure, such a pressure is called as maximum pressure. Remember this, what exactly I'm trying to show. Most important guys. Next. Now you remember this equation, the final torque equation. If you are trying to find FA from this equation, so let me say FA we have already found by using this formula, half pi p d1 into d2 minus d1. But if there is other way of finding FA. FA can also be found by the equation which is shown now, the torque equation. If you are trying to find FA from this equation, such a FA is called as actual or applied force, applied axial force. So remember this guys. So FA was determined from the other equation which I am trying to show on the screen. Okay, this equation is called as actual or applied axial force. Actual or applied axial force. Okay, this is what exactly we will be trying to talk about. So once again, use this FA in this equation. If you are going to use this FA in this equation and find P, and if you are finding P, such a pressure is called as actual or applied pressure. Such a pressure is called as actual or applied pressure. So remember this. If all you are trying to find, if in the exams, determine the actual pressure. So what you are going to find? You will try to find FA. You would have already found FA by some equations. Let me say you have already found FA from this equation. But still, if you ask axial force, so maximum pressure, you can find this. If he is asking actual pressure, then once you can find the value of FA using torque equation, then you have got FA. Substitute FA value in this equation. Okay, substitute FA value in this equation. Now after substituting FA value, then what you will be trying to do is you determine the pressure from this. It is called as actual or applied pressure. Now in most of the problems, what happens is, just now when I was referring question papers, they were not asking actual pressure. In some problems they started asking average pressure guys. Okay, yesterday also someone has asked mean pressure. They were asking mean pressure. So what to do with this mean pressure? Now most important guys, if they ask something called as, see, they have not asked maximum pressure, they have not asked actual pressure, but still they are asking something called as mean or average pressure. So that is what exactly they are trying to ask. So mean pressure or average pressure. So in such cases, what exactly are supposed to do? Now listen guys, you use this equation first. You will be finding Fa as usual. So you will be finding Fa. The Fa is called as axial force. Now you will be using this equation. Can you see the changes in the equation? Can you tell me what is the difference in this equation? Small change is there in the equation.
Mean diameter is used.
Correct. So usually this equation should be D1. This equation should be D1. But since I am trying to find the mean pressure, you are supposed to use dm and find the P. You are supposed to find dm and find the P. Most important guys. So here this is what exactly the mean pressure or average pressure talks about. You will be finding the mean pressure by taking these values. Okay, so dm will be using it. Okay, instead of Fa. Instead of d1. Now such a pressure which we try to talk about mean pressure. So remember this. So once again guys, I have three types of pressures which is most important, which you need to understand. One is maximum pressure directly from this formula Fa. Okay, now you have actual pressure. Actual pressure means you go for MT, find Fa, then once again in Fa, from this Fa equation take P. If D1 is there, then actual pressure. Now if he says mean pressure, mean is average. So at the mean diameter we are going to find. Instead of D1, we'll be trying to find at DM. Instead of D1, we'll be trying to find at DM. So this is your mean pressure. This is what exactly you need to do it. So most important guys, if this is the process, how exactly you are supposed to do it. Neatly explain the process. So with this, we'll be starting these problems. Now here also, question number 6. When I say mean unit pressure, in yesterday's class I used D1. Instead, I want you to use DM. Instead, I want to use DM in question number 6. Anyhow, we'll be trying to solve this question number 7. The combination of 6 and 7 is question number 8. We'll be trying to solve question number 8 so that the students you can clearly understand how this problem will be solved. Hope 6 and 7 we have already done in the last class. We'll go with question number 8 guys. Now anything you would like to ask me now? Anything you would like to ask me before I start this class? Anything you would like to ask me? Any questions? Any questions guys? Did you understand? So I got 51. Any questions?
Sir,
Yeah,
I should be always positive one. Sir.
What one?
Even. Sorry, I should be always even. Even number one.
No, I should be always even. I should be always even because we have a formula in this case I by 2 always. If you remember here, I am taking the value as I by 2 here is. Now try to see. Here I by 2 I should take. If I is odd number, then it will be 0.5. Once again here I need to round it up. So in this case it should be always even number. Always even number. Is it clear?
Sir.
Right. Any other questions guys? Any other questions which you'd like to ask me? Try to feel comfortable guys. Nothing wrong actually. If you are sitting at your home, so once again it is a kind of online class, so nothing to worry. If you have any doubts, please ask me. Okay. So any questions in this concept? Is it clear? So you have this concept. So let me start with question number 8. So try to go through this question number 8 here. So question number 8 which we are going to solve. Okay. Hope you have your books with you, notebooks. Please keep the notebooks and start parallel writing with me. I am taking extra effort to teach you. Else I could have taught in the way where entire thing I would have shown in PPT. But I felt that obviously this is more comfortable. When I write it, you also will have some time to understand. That is the reason which I started writing by myself, each numerical. Now, a multiple plate clutch. So the type of clutch is multiple plate clutch, has steel on bronze. What does it mean? Means the flywheel is made of steel and there is a bronze friction plate. Is to transmit 8 kilowatts at 1440 RPM. So capital N he has given. How much is capital N? 8 kilowatts. I want the interaction to be on. So in this case, capital N power here is given 8 kilowatts, small n 1440 RPM. 1440 RPM is given. What else is given? The inner diameter of the contact is 80 mm. So once again, in diameter D1 is 80 mm here is given, and D2, how much is this? 140 mm. D2 140 mm. Here is given a value. The clutch operates in an oil. So by default, multiplied clutch will operate in oil with the expected coefficient of friction of 0.1. He has given the value of 0.1 as coefficient of friction with an allowable pressure of 0.35. So once again, P is equal to 0.35. Sorry. With the allowable pressure of 0.35. Now he says, assume uniform wear theory. So we have a theory which we have uniform wear theory, which we are going to work. Okay, and what exactly you are going to determine? The number of steel and bronze plates. Okay, so to find, can you tell me what is this value? To find what? First one, A. What is the notation which we are going to use?
I1 and I2.
Very good. I1 and I2. I1 and I2. Now, axial force required, B. So, FA. Now, actual maximum pressure. So, actual maximum pressure. So, I can say that P maximum, which you are trying to find. I'll tell you the process, how exactly. P maximum to be found by using FA. This FA will be found by using MT. This is the process which you are going to use. Now he says D, the average pressure. Now this average pressure will be using FA, but instead of D1 we will be using DM. Instead of D1 we will be using DM. Then we will be using this FA will be found by MT. This is the process. This is the process which we will be trying to find. So how exactly we are trying to find this pressures? Okay. Now this is the things which has been asked. Let me solve the numerical for you. Okay, given in the external examination for 10 marks, guys. This I'll be giving you the notes. Even I'll be trying to share my scanned copy of notes as well as the questions. So kindly go through it. Maybe tomorrow's class, by Monday's class, once the entire chapter is done, I'll be trying to share it off. How do we solve this numerical? So given data is there, everything. Let me start with torque equation. Your first equation is your torque. MT is equal to 9.55 into 10 power of 6 multiplied by capital N by small n, which should be equal to 9.55 into 10 power of 6 multiplied by 8 divided by 1440. How much is the value, guys?
530.
530.55.
Yes, sir.
Newton. So I got the value. Next, step number 2. So you have DM directly, mean diameter. So D2 plus D1 by 2. Because uniform wear theory, uniform wear theory, the formula is simple. So D1 plus D2 by 2, you have got this value. So how much? So D2 is how much? 140 plus 80 by 2, how much? 110. 110 mm. We got 110 mm. Okay. Now, once we got this, what will be the next step? Axial load. So axial force, FA. We have axial force FA. Now, what is this axial force talks about? FA is equal to, you write the formula. FA is equal to half pi P D1 multiplied by D2 minus D1. This is the formula which we will be trying to use. So it will be equal to half into pi into pressure. Pressure is given as 0.35. Diameter 80 into 140 minus 80. How much? How much?
2,638.
0.93. 2638.93. Yeah? So you got axial force, then your next step, you have torque, equation, because my focus is to find I1 and I2. So MT is equal to half mu FA dm into I. So wherever possible, write the equation numbers. Equation number 19.83, equation number 19.84. You have the equation numbers here. Okay, you'll be using the equation numbers. So will be equal to MT. You have got 53055.55 half into mu is 0.1, FA 2638.93 into dm 110 into I. So what is the value of I, guys?
So 3.6.
So 3.65. So 65. So will be approximated to what?
4.
4. The highest even number will be approximated to highest even number. You got the value of I as 4. So once I is there, so next one, what we'll be trying to do in this case, determine the value of I1 and I2. So I1 is equal to I1 by 2. Sorry, I by 2. So 4 by 2 is equal to, yes or no? So here nothing but number of bronze plates. These are the number of bronze plates, guys. Always see, remember which. Now here he has asked, shall I consider steel plates or bronze plates? Always remember this. Less number of plates will be for the friction plates. In this case, less number of plates will be for friction and more number of plates will be for steel, because steel will be on the hub side. So once again, I1 and I2. I2 is equal to I by 2 plus 1. So once again, 4 by 2 plus 1 is equal to 3. Now therefore, so I1, I2, but write down total number of plates also. Total number of plates, 2 plus 3, total number of plates 2 plus 3 is equal to 5. So you have got your answer. Okay, A is done. Now we'll go for B. B, what is asking? Axial force. We have already found axial force, but still is asking. So once again, I'll write the axial force. FA is equal to 2638.93 newtons. We have found. This is what we call it as. We call this as limiting axial force or maximum. The maximum value. Maximum. Okay. Now the question is the actual axial force. How do I find this actual axial force? Can anyone tell me? Actual axial using
Torque equation.
Great. So we'll be using torque equation. Therefore, we know that MT is equal to, we have this formula, half mu FA dm into I. Why it would have been changed? Because all of you listen, guys. The value of I is supposed to be 3.65, but what you have done, you have rounded off to 4. So that is one of the reason why this FA will also change it. So instead of 3.65, you made it 4, the highest even number. So, and you will be using 4 here. That is also one of the reason why FA will be changed here. So once again, substitute by this value, 53055.55 is equal to half into 0.1 into FA multiplied by 110 multiplied by 4. Tell me the value of FA now.
2411.62.
2411.62. So you got this. So B is also done. C. So he says the maximum pressure actual. Okay, maximum pressure. Okay, P. So you have this P, maximum pressure, which we are going to use it. Now when you are going to use this pressure, see, when it says, see, there are two different things now. Actual maximum pressure will be, see, actual FA is this one only now. So actual FA is this 2411.62, which we will be trying to use it. So we will try to go for this actual pressures. Now we know that FA is equal to, we have the formula FA is equal to half pi P D1 minus D2. You have this values. Now substitute this value 2411.62 half into pi into P, let it be P, D1 is 80 into D1 140 minus 80. How much is the value of pressure? How much is the value of pressure now?
.319.
0.319. Yes, 0.319. Okay. This is the pressure which you have got. Now, final thing is most important. What is that? Average pressure. Average pressure. It is also called as mean pressure. Mean pressure. So we'll be finding this pressure at the mean diameter. So we'll be using the equation FA is equal to half pi P. Instead of D1, we'll be using DM, D1 minus D2. So you need to be, see, the familiarity should be there with the statement of the question. Average pressure, what exactly you need to do. Maximum pressure, what exactly, or actual pressure, what exactly you are supposed to do. The statement should be having a clarity. So 2411.62 is equal to half pi P. What is the DM? 110 multiplied by 140 minus 80. What is the value of P now?
0.23.
3.08 into 10 power minus 5.
0 point?
Sir,
No,
it should
no.
be D2 minus D1, no, sir.
P.
In the equation you have written D1 minus D2, sir.
Okay, sorry. D2 minus D1. D2 minus D1. Sorry. Thank you. P2 minus D1. Right. So what is the answer? 0.23, yeah?
2327.
2?
2327.
Okay. Right. So you have your values. So this is your 10 marks. 10 marks per all this. Slowly you will be trying to. So most important, what exactly the examiner should know, that you have, the examiner should have a clarity. What exactly you are writing. Okay. In which steps you are writing it. The steps which you are writing, you should be more clear. In which steps you are reading, what are the problems you are trying to solve. Is that clear? Any questions? So once we have got this, any questions you would like to ask me now? So once again, this try to see the numerical how we are solving. You solve something like this. First, you solve with mean average pressure. Okay, let me make it. Okay. In this case, you started with what exactly is this pressure? Okay, speed he has given, n he has given, the value D1 he has given, D2 he has given, mu P, uniform wear theory. What exactly we have to find? So this is a given data part. So the part which you have seeing on the screen is a given data. Once you are comfortable with the given data, then we start writing the equations. The first equation empty. Okay. You have your equation as empty in this case. Now in this empty equation, ensure that obviously whenever you are trying to write this equation, okay, now whenever you write this equation, ensure that this all the data is ready, and n should be always in kilowatts. The n should be always in kilowatts. Let me say okay. In this case, this should be in kilowatts, and this should be in RPM. This should be in RPM. Most important is kilowatts and RPM. Okay, the unit which you are going to get will be in terms of Newton. Once you are done with this step, so you have done with your MT. You are done with your MT. Once you are done with your MT, next go for DM. DM also you can write the equation number. So you have got average equation. Then go for FA. So most important FA here, axial force. Okay, once you have got this axial force, you have got 2638.93 as the axial force. Then find the I. This is what exactly is the expectation from especially multiplied process. So here when you go for I round it off to next highest even number. You got this value of I. Once you got the value of I, once you have got this value of I, then you will go for the value of I1, the value of I1, the value of I2. You got the value of I1 as well as value of I2. Okay. Now once you have got, this is what exactly it is expected, you write it here also. So this is number of bronze plates and this is number of steel plates. Number of bronze plates and number of steel plates. This is what exactly the values. Okay. Once you are done with this, you go for axial force. Find the axial force. But this time we'll be finding the axial force. First, we'll be finding from this equation. We will try to find. Use this equation. From this equation, I'll be using the value of FA. Okay. Now here, when you go this same thing here, I use equation MT. From equation MT, I'll find FA, which I have already found in the previous step. From FA, I'll be finding P. From FA, I'll be finding P. Now the last one, what happens? I have used MT. From MT, I have used FA. While in FA, through FA only I have found P. Only the difference is I'm using DM. This is what the steps which we are done. This is what this average pressure. So this is your marks list. This is how the marks will be given. So clearly you write each and every step. Right? So shall we go for the next numerical? Sorry, yes. Right. So once again, the next one, question number 9. So once again, question number 9. Hope now from here the questions are very simple. You don't have much difficulty in solving the questions. Let me say question number 9. Quickly read it and solve it. We'll try to solve this question number 9 easily. All these questions from now, whichever I'm trying to show it, they are from your external examinations. All the questions are from your external examinations. A multi-plate clutch has 2 bronze and 3 steel discs. So what has he has given? Can you tell me now what is the data? Now please say wait.
I1 is 2 and I2 is 3.
Very good. Q9. I1 is equal to 2 and I2 is equal to 3. I2 is equal to 3. Okay. This is the data which has been given. Sanjit, unmute yourself. Sanjit KS.
Yes, sir.
Yeah, you tell me the data is. Sanjit will be telling data for all of us. Please tell me. Fast.
Sir.
So next what? Sanjit, next
The
what?
friction material.
No, don't read.
Yes,
Tell
sir.
me the notations.
Sir, P is 0.1 Newton per millimeter square.
P, right. P.
Pressure.
Okay. Just tell P.
And mu
Mu.
is 0.15.
Done.
And D2 is 200, sir.
Right. Next.
D1 is 120 millimeter.
Right.
We should find N.
Should find
N, sir.
small n and capital N.
Capital, sir.
Capital N. Done.
Small n is 1000 RPM.
Right. Any questions, guys? Easy. Can we solve this numerical? So, Sanjit.
Yes.
So, yeah. Okay. You can mute yourself. I have got Shamant. Unmute yourself. Shamant Gowda. Shamant. Can you hear me? Hello?
Yes, sir. Yes, sir.
Okay. Now, first step.
Hello.
Yeah, first step, Shamant. I can hear you. First step, Shamant.
Yes, sir.
What is your first step? To solve. So guys, Shaman is not there. I have got Tilak. Tilak, unmute yourself. Tilak, how do we start the problem? Fast. Remaining students. Now start with
Empty.
empty. Yeah.
Start.
Think. Is it empty required at the starting itself? Because we need to find empty. If from empty only I am going to find n na. Do we have dm directly. Now one more condition which we need to assume, which is that uniform pressure or uniform wear.
Uniform wear, sir.
Correct. So you need to write here, assuming uniform wear theory. Assuming uniform wear theory. Now let us start our numericals. Now our equations first. Since empty we need to find from empty, see, you should have entire picture in your mind. How do I find n? N can be found somewhere in the rough work, you can do it. N can be found by using empty. So empty is the parameter which will be found at the last. So we'll try to keep it as it is. So after empty, what is your first step? You have mean diameter. Okay, you have mean diameter. So you have your mean diameter. Mean diameter is given as dm. The formula is d1 plus d2 by 2. You have d1 plus d2 by 2. Once you have got this d1 plus d2, whose value will be equal to dm is equal to 200 plus 120. Okay.
160.
So, how much? 160. Yeah.
Yes, sir.
160. Yeah. You have got dm. Once you have got this value, the second step.
Axial force.
Axial force. Axial force will be equal to half pi p d1 d2 minus d. Right. So substitute the values of all the values you have given. P is known 0.1, d1 is not, everything. How much is the answer, man? Substitute all the values.
1507 point.
Point
96.
So I got this one. Now third step, dot mt is equal to, once again, half mu fa dm I. So you have the value of torque. So here don't forget, write the equation numbers if required. Equation 19.84. So here what exactly you are going to determine now. Now the question is I. What is the value of I, guys?
I1 into
I1.
2I1.
I1, what can you tell me the value of I? Anyone now? Most important.
4, sir. 4.
I is 4. Great.
Number of
Because see, first let me see total number of plates. Here, total number of plates is equal to I1 plus I2. So is equal to 5. Yes or no? 2 plus 3. I1 plus I2 is equal to 5. Now here what exactly happens in this case? But the number of active surfaces. Number of active surfaces will be always less than 1. Yes or no? I1 plus I2, I is equal to I1 plus I2 minus 1. This is the formula. So once again will be equal to 5 minus 1, 4. The value of I is equal to 4. Now substitute this values. Now MT is equal to. So how much, when you substitute half, what is the value of mu? 0.15 multiplied by FA, you have got 15. 07.96, dm you have got 160, and I is equal to 4. How much is the value of MT1?
72.08.
382.08
Yes, sir.
Yes, sir.
Newton. So you got MT also. Now once you are done, we know that we will be writing once again, right? We know that torque MT is equal to 9.55 into 10 power of 6 into capital N by small n. Capital N by small n. Now you substitute everything. You substitute the value of empty here. You substitute the value of small n here, and give me the value of capital N.
7.57.
7.57.
Very good. Great. That's it. This is your 10 marks. This is your 10 marks. That's it. You are very much strong in this this one. For students who are some students who are unable to follow, I kind of go through my recorded videos, and it will help you guys. It will help you a lot. Okay, and so we'll go for next problem. Next problem is ready for you. Question number 10. So any questions in this previous problem, you can ask me. Any questions in the previous problem, please ask me. Very simple numerical. Question number 9 is very simple. All right. So go for question number 10. Question number 10. Right. Question number 10. You have once again on the screen, guys. I want you to be ready with the answers. Very quick answers is very much appreciated. Thank you very much. So question number 10. We'll solve the problems and we will finish it. Question number 10. A multiple disc clutch has 5 plates. Okay, what having 4 pairs of active friction surfaces. What does it mean? Can you tell me now?
I.
Small I equals 4.
Small I is equal to 4. And what is 5?
Total number of
Total
I1 plus I2. Right. I1 plus I2 is equal to 5. I1 plus I2 is equal to 5. And he has given I is equal to 4. I is equal to 4. If the intensity of pressure is not to exceed 0.127, so once again P 0.127 Newton per mm square. Find the power transmitted at 500 rpm. Power transmitted obviously at 500 rpm, small n 500 rpm, and to find capital N. Now, the outer and inner radii of friction surfaces are 125 mm and 75 mm. What is this?
radius.
Listen, guys. This is exactly the same question 2 years back. It appeared in your external examinations in your seniors. What happened is the entire concept was same. Unfortunate thing is the students were so much eager to solve the problem. Instead of radius, they have taken this as diameters. So most patience you should have while reading the question and transferring the question into the data. This is where exactly the art of doing this is most important. See, after this doing this calculations, anyone can do it. That is not an issue. But 50% of your strength lies in how do you understand the question. What is the question? Spend more time in reading the question rather than in solving. You read much, you try to have this, you make this analogy, you make the process in your mind, or try to make a rough what he has given. If not once, twice, thrice you read the question, but don't make mistakes in reading the question there. So he clearly said outer and inner radii. So instead of diameter, it should be radius. So once again, the outer radius, it is R2. He has given us 125 mm. So which clearly says that D2 will be equal to 250. D2 is equal to 250. And R1 is equal to 75 mm, which says D1 is equal to 150 mm. 150 mm. Assume uniform wear. So once again, uniform wear theory, and take coefficient of friction mu is equal to 0.3. Now uniform wear which we are going to use. Wear theory. So once again, guys, this is a numerical, very simple, same as previous step. Step number previous question number 9. Everything is been given. Question number 9. So how do we solve? As usual, same thing. First one is, I'll quickly tell me the answers. We start
Main
with
element.
Yeah, TM
200 mm.
200 mm. All right. Your second step, FA half. So this is how we got D1 plus D2 by 2. I have got 200 mm from this formula. So second question, half pi p, you have d1 into d2 minus d1. So how much is this answer?
299
299
2.36.
0.8.
I didn't understand. 299
2992.367.
367. Fine, I got this value. Now point number 3, you have torque mt. Mt is equal to half mu fa dm into I. Okay, now I has been given clearly as 4, so mu has been given, fa is known, dm, try to all of you see here, hope see every one of you are doing this, try to solve it. Kindly do it, man, kindly do it, obviously, because what happens, we may not have much time in once you come back offline. And other section, I heard that other section already went into brakes. I'm still in clutches. Okay, they are trying to solve brakes. Krishna Rao sir is doing in brakes. Slowly will go, but I felt that obviously your basics should be strong. More problems I want you to solve. So what's saying, guys? Come back. Tell me.
3,59,084.
3,59,084. Any decimals?
0.043. 0403.
Okay, then Newton. So you have got this value, very simple. Then we know that once again the torque 9.55 into 10 power of 6 multiplied by capital N by small n. Capital N by small n. So once again here we'll be finding the value of n. We'll be finding the value of n. How much?
18.8 kilowatts.
18.8, sir.
18.7.
18.8 kilowatts, huh? Right. Thank you. Okay, this is how we'll be trying to solve the numerical. So you have done with your question number 10. Any questions now? Anything you'd like to ask me? Question number 11. So quickly we'll solve it. So that today we'll be completing multi-plate clutches, and next class will be immediately starting with cone clutches. Cone clutches, 2 classes or 2-3 hours. Once we are comfortable with cone clutches, this entire module will be done. Any problem in your external question paper, you will be able to solve it. Okay. Now you have something called as at this time, since you are solving many in multi-plate, I thought of giving you a question in single plate clutch also this. So that is the reason which I have brought in between. And here see, in single plate clutch, this fellow has asked average pressure also. So we'll try to solve single plate clutch, because you are in a rhythm of multi-plate. We'll try to solve single plate also. Single plate clutch. Once I come back, so that you can recall the concepts of single plate, how the difference. Now a single plate clutch having both sides effective. What does it mean? Having both sides effective.
2 friction plates, I equal to 2.
I is equal to 2. Both sides effective is I is equal to 2. Okay, that is what exactly it says. Okay. Transfers. So second power, capital N, 25 kilowatts. Capital N, 25 kilowatts. Transfers 25 kilowatts at 900 RPM. So small n, 900 RPM. Okay. The maximum pressure intensity between the plates is 85 kilonewton per meter square. What is this? What is this?
Sir, 0.085 Newton per annum.
Very good. 85 kilonewton per meter square. How do I understand this? So will be equal to 85 kilo means 10 power of 3. For 1 meter it is 10 power of 3. So for meter square 10 power of 3 into 10 power of 3. So will be equal to 0.085 Newton per mm square. Newton per mm square is also called as megapascals. Is also called as megapascals. It is 0.085 megapascals. Not yes, the value. Okay. The outer diameter of the plate is 360. So outer diameter D2 360 mm, D2 360 mm. So you got, if the coefficient of friction between the contact surfaces is 0.25, so as given V is equal to 0.25, as given this. Determine the inner diameter of the plate. So what is D? What is D1? Then what else? Axial force required. Axial force required to engage the clutch. FA. FA to engage the clutch. Average pressure between the contact surfaces. Now here see P average is asking. See P average. If you are trying to find the P average, you should find DM. In DM has to be substituted, then you will go for P average. So now, so what kind of clutch is this? What kind of clutch is this?
Single plate.
Single plate.
And which theory we are going to use? Uniform wear theory. We are going to use uniform wear theory. Yes, we are going to use uniform wear theory. So let me start with this numerical. Your first step. So capital N, small n is given. I'll go for empty. Okay, empty is equal to 9.55 into 10 power of 6. Now try to see single plate or double plate clutch. The procedure is same. Okay, 9.66 into this one. So once again you have the value.
265277.78.
5277.78 Newton mm. Newton mm. See, whenever I am solving the problem, I never missed a single unit anywhere. Whenever I have written the answers, their unit is by default. So unit should be a part of your answer. Without the units, you should never solve it. So once again, we are done with this. Second one is DM. So D1, okay, D2 plus D1 by 2. D2 plus D1 by 2. So D2 is, so half into 360 plus DM. Yes or no? Half into 360 plus DM. This is the value because we are supposed to find the value of D1. So can you see, whenever single plate clutch came into picture, the major unknown became diameters. Whenever the multi-plate clutch comes into picture, the major unknown will become the I value, the number of friction surfaces. So we got this value of DM. Then next step, let me change the page for you. Once you are done with DM, the next step will be FA. Okay. Now let me say step number 3. FA is equal to half pi P D1 D2 minus D1. So once again substitute back will be equal to half into pressure how much? 0.085. So divide it half into pi 0.085. D1 is unknown, multiplied by D2 how much is given? 360 minus D1. This is your this one. So once again, remember, let it be D1 into 360 minus D1 as it is. Okay. Point
0.1335.
D5 D1 360 minus D1. D1 360 minus D1. This is your answer. So step number 3 is done. Now I got step number 4. Now step number 4 empty. Empty is equal to. Okay. Now you have half mu FA DM into I. So you have your value. So FA empty we have already found. What was the value? 5277.77 is equal to half into mu. How much he has given? What is the value of mu, guys? Friction is 0.25 into FA 0.1335 into D1 into 360 minus D1. We have 360 minus D1. Okay. Multiplied by DM. So once again, What was the value of dm? Half 360 plus 2 plus d1, 360 plus d1 multiplied by I is equal to 2. So now all of here when you are trying to solve this problem, when you are trying to solve this, now you keep this, you make use of this mathematical this one, 360 plus d1 and 360 minus d1. It will be 360 minus 360 square minus d1 square. This is what exactly we will be trying to use it. So once you are done with this, come back with this analogy. Now you have this 2652 77.77 will be equal to. So once again, how much is the other value? Leaving this everything d1 into this, what is the other value? How much you will be getting? You have something you will be ending up with. If we calculate 0.01667 d1 into 360 square minus d1 square. This is the equation which you are going to get. Once again, 265,277.77 is equal to. So multiply it 0.01667. Okay, it will be ending up with. Let me calculate it for you. So it is 2162.71 minus 0.01667 d1 cube. Now you will be getting the values of d1. You will be getting the values of d1. What is the value of d1? How much is the value of d1?
95.65, sir.
How much?
95.65.
I have got different answers, guys. I have got different answers.
So one is 262.181 and another is 148.27.
Right, correct. This is the right value. So
140.
yes. See, 140. What I have done, let me show you. Okay, here
147.3.
147.29.
Yes, sir. 147.
147.29 and okay, or you have got
263.
1201. These are the two values which are available. Okay, now which value should be selected? Which value should I be selected?
147.
Yeah, select the minimum value for D1. If it is D2, which value should have been selected?
263.
Yeah, maximum value. So selecting minimum value. Okay, to accommodate more surface area for friction. This is the reason why I am trying to select it. Selecting minimum value to accommodate more surface area for friction. I am selecting D1 as therefore D1 is equal to 147.29. So D1 has been found. Once D1 is found, he expected me to find FA. So I will be trying to find all the values. D1 is known. Now axial load, axial force, FA. We have the value 0.1335 D1 into 360 minus D1, which we have already found. So once again substitute back, and how much is the value? Substitute back the value of D1 here. Substitute back the value of D1.
418.21.
How much? 41?
82.21.
4182.
4182.21. Okay. Yeah, got this one. Yeah, ended up with this one. Then obviously next one, what he has asked, what is the data he has asked, guys. So I have done with the okay here now. FA is done, average pressure. Now we are going to find this average pressure. So find this FA. All of here now. The point is to find the average pressure. What is our process, guys? What is the process?
Yeah, in diameter.
Mean diameter. Okay. So he asked the mean diameter. So we'll try to find the mean diameter. So mean diameter. First we'll find mean diameter. Mean diameter dm is equal to half. We have got 360 plus d1. How much is the mean diameter we got?
253.64.
253.64 mm. Now we go with the formula MT. Yes or no? We go with this formula MT. Now here MT is equal to. Shall I go with the formula MT?
FA is equal to half P into dm into d.
FA is equal to half pi P. Now instead of this one, I go for dm. dm multiplied by d2 minus d. It is dm, guys. So most important, because I am trying to find what average pressure. I am going to find average pressure. So since average pressure is there, we are going to use the concept of dm. We are going to use the concept of dm. So once again, FA 4182.21 half pi P into dm 253.64 into 360 minus 253.64. How much is the answer of P?
0.155 MPa.
0.005.
Point 0.05 MPa is the right answer. 0.05 MPa is the right answer. You should be very careful, guys, in calculating. You should be very careful. You should be serious in calculating. Now, anything you'd like to ask me now? Any doubts or any questions? So you have done it. Tell me.
Sir, D1 to 147.
D1, huh?
Sir.
Yes, na?
Last
D1?
equation, FA.
FA is
DM
2 minus d1 value dm value.
Equation alli dm. Here. Oh, sorry. It should be dm. DM only, no? We should. How much is DM?
D1
D2 minus
minus d1 alone.
No, No, I one off here.
D1 value should be 147.29, sir.
ಯಾವುದು DM
D1.
Okay.
Yeah, wrote
Value actually minus dm value d1 value.
Hey, listen. The concept is very much clear. It is the average pressure. The average pressure or mean pressure happens at mean diameter. Average pressure or mean pressure happens at mean diameter. All of
inside the bracket, sir. Inside the bracket, you have substituted DM's value instead of DN. D1.
Oh, here, sorry. 147.2. Thank you, ma'am. Okay, sir. Right. D2 minus D1. D1 is 147.29. That is the reason in which you are getting it. I'm really sorry. It is my mistake. Right. So 147. Is it now? Is it clear?
Yes, sir.
Right. Thank you. So this is how exactly we'll be trying to solve this numericals, guys. Let me change this. We'll go for the next numerical, because see, today's class I felt that we'll solve more number of numericals. We are not going to touch back. When we come back to offline also, we are not going to solve this exercises, because we know we have done it clearly and completely. What we'll try to do is we'll go for in offline we will not touch clutches system. That is the reason which I wanted you to be more concentrating on this topic. Okay. Once we are done with this, 2 more questions. I will stop it. Very simple questions. All the questions. Do you know one thing? All the questions which we are solving right now are from the external papers. All the questions are from the external papers. Each question for 10 marks, 20 marks, all things. So from Monday, will be one more topic is there. Cone clutches. Once cone clutches is there completed, we'll be trying to stop it. And 15 and 17 scheme students. Can you tell me when do you have your classes? Your afternoons. The some other students you don't have much classes. 15 and 17 scheme. Let me see. Ranjan. Ranjan is there?
Yes, sir.
You have got some message? Anything?
Sir, I got logged out, sir, that time.
Now you came out.
After
you
that,
came. Yeah, you were connected, right?
Yes, sir, yes.
Sir, it's on Wednesday and Friday.
Okay, it is on Wednesday and Friday. Yeah? Then Monday and Monday also I can take in the afternoons, right, for you?
Yes, sir.
Okay, Monday, guys. If you see this Monday, I have got second hour. Okay, and second hour I have got on Monday. So what I'll be trying to do is I'll be taking on second hour as well as in the afternoon. So both the classes I'll be taking it. Okay, that is how I'll be trying to take the class. Keep attending the classes. So once again, just now we have solved which question. Question number 10 is done. 11. Question number 11 ಮಾಡಿದೀವಾ? No.
Yes, sir.
Question number 11 is done.
Yes, sir.
Still question will be touched. Okay, just now we have done question number 11 only. Then we'll go for question number 12. So two more questions, guys. That's it. Two more questions. And recent questions. Question number 12. Quickly we'll solve it up. This is, I think you can solve it more easily now. Question number 12. A multi-disc clutch has 3 discs on the driving shaft and 2 discs on the driven shaft. So can you tell me the values?
2, 3 and I1.
I1 will be always a smaller number. I2 will be always a larger number. Simple. I1 is equal to 2, I2 is equal to 3. Okay. Now, so what should be the value of I? I is equal to 2 plus 3 minus 1 is equal to 4. This is the value of I. So see, he has given the value. I1, I have got I2 also. Okay. I2. Okay. I2 is equal to. Now, next, the inside diameter of the contact surface is 120 mm. Can you tell me what is this? D1. 120 mm. So the maximum pressure between the surface is limited to 0.1. So P 0.1 MPa. 0.1 MPa. Calculate the outside diameter of this time D2. We are trying to find D2. Okay, of the contact surface for transmitting 25 kilowatts, capital N, 25 kilowatts. Then what else he has given? Speed N, 1575 RPM. 1575 RPM. Assume uniform wear condition at coefficient of friction of 0.3, mu 0.3. Uniform wear. We are going to use uniform wear. This is what exactly the problem which we are going to solve now. So let us see the numerical which we are going to solve. Okay. Now how do we start this? So start with as usual. Since first one is top. So make it fast now. MT is equal to 9.55 into 10 power of 6 multiplied by capital N by small n. So substitute back here. Now I'll make this only. Substitute back the values and tell me the answer. Okay. N is 25 kilowatts. This is 1575. How much is the answer?
151587.3.
151587.3 Newton. Right. I got this one. So once it is done, then the second part dm. Okay, it is half D1 plus D2 or D2 plus D1. Anything is fine. So D2 half D2 plus D1 given as 120. D2 given as 120. So you have done with the second part. The third part of the equation, FA, you have FA. FA will be equal to half uniform weight theory pi P D1 D2 minus D1, D1 D2 minus D1. So once again guys, here you will be trying to substitute the values, and you substitute the values. Now here when you are trying to substitute the values here, okay, let me how to substitute it. So will be equal to half pi P here is given as 0.1 multiplied by D1 is 120, D2 is unknown, minus D1 is 120. So will be in terms of D2 minus 120. The value will be in terms of D2 minus 120. How much? D2 minus 120. Okay. Past.
18.84 into D2.
What?
18.84.
18.84 into D2 minus 120. 18.84 into D2 minus 120. We have got this 3, step number 3. We got step number 4. Step number 4 is empty. Empty is equal to half mu FA DMI of mu FA DMI. So you have this value. I'll be substituting it 151 587.3 of mu is how much? You have the value of 0.3. FA 18.84 D2 minus 120 multiplied DM is half D2 plus 120 multiplied by I is equal to 4. I is equal to 4. So once again here we will be trying to make use of this mathematical, this one A plus B into this A plus B into A minus B, A plus B into A minus B, so that this will become easy for us to solve. So A plus B into A minus B, you have ended up with this. So once again I will get 151,587.3 will be equal to what?
Sir, 203. Answer.
Answer is 203. Okay, directly you have put the answer. So okay, fine. I think this so right, it is 5.65 D2 square minus 120 square. So D2, how much? 20?
Sir, 203.
That's it. Any points? Decimal places?
4.
Okay.
202.9.
Right. That should be fine. Very simple. Any other things he has asked? Only D2 he has asked in the numerical. Nothing else. Calculate the outside diameter of the contact transmitting. Yes, done. Your problem is done. Nothing else. Because when he asks, whatever he asks, when he has not asked design, do not solve unnecessarily all things. He clearly asks whatever he needs it. So that is what he has asked us. So you have with your question number 12. Question number 12. Any questions, guys? Any questions you have? Sorry. So any questions you have? Now last question for this today's class. After this I will stop the class. Okay. Question number 13. This has been given in December 2016. This is also very much simple question. Question number 13. Okay. So once again, Q13, which we will be trying to solve. A multi-plate clutch consists of 5 steel and 4 bronze plates. What does it mean? Which is I1, which is I2?
The bronze is I1.
So I1 is 4.
Yeah.
I3.
Very good.
I1 is 4. Is 5.
4 and I2 is equal to 5. Once here is given, first we will find I. I is equal to 4 plus 5 minus 1, so 8. So we will complete this one. So it is done. The inner and outer diameters of the friction disc are 75 mm and 150 mm. D1 75 mm, D2 150 mm, D2 150 mm. The coefficient of friction is 0.1. Mu is equal to 0.1. Okay. And the allowable pressure to be limited is 0.3. P is equal to 0.3 megapascals. Assuming uniform pressure. Now try to remember, guys, this is uniform pressure theory which we are going to work. Assume uniform pressure. The required axial force. Now what exactly is their axial force required? Now he never asked maximum. He asked the required axial force. The power that can be transmitted is 750 rpm. Capital N. How much? At small n is equal to 750 rpm. Okay, these are the two values which he has asked for 10 marks. So to this one, so once again, now try to listen, guys. The theory is till now we have done once again uniform wear theory. Now we will be working on uniform pressure theory. It is a multiple disc clutch. Okay. Now how do we start this numerical as usual? Start with we start with DM always. We start with DM. Okay. Now the formula of DM is not D1 plus D2 by 2 anymore. Now according to uniform wear theory, pressure theory, DM will be equal to 2 by 3. Always remember this formula, D2 cube minus D1 cube divided by D2 square minus D1 square. D2 square minus D1 square. Okay. Now this is the equation number which you need to write it. Equation number 19.85a. Equation number 19.85a. So substitute back 2 by 3 D2 square 150 is a DD cube, 150 cube minus 75 cube divided by 150 square minus 75 square. How much is the answer is?
116.66.
116.6.
667. 116.667. So once you are done with this, the second step, the axial force, FA. The axial force FA will be equal to pi P. It is not half pi P because it is uniform pressure condition theory which we are working. Pi P D2 square minus D1 square by 4. This is the actual, guys. This is a maximum value which we are trying to find, but the required is this one different. So once again, pi into P is given as 0.3. So D2 square is how much? 150 square minus 75 square by 4. How much? So FA fast.
3976.07.
How much? 2?
3976.07.
39?
76.
76.07.
76.07. Right. I got the value of this one. Now, once you are done with this, next we have the equation top. This will be the same irrespective of both the theories. This will be the same. Half mu FA. You have got FA DM I. Half mu FA DM I. So once again, we go to start half mu is 0.1. FA is 3976.07 into DM is how much you got? 116.66. I is how much? We have got 8. I is 8. So you have got empty. How much is this empty?
185539.33, sir.
5539.33, yeah?
Yes, sir.
Right. So we got this one. 185539.33. So you have got MD. Now the next step is, we know that MT is equal to 9.55 into 10 to the power of 6 into capital N by small n. Okay. So once again, I'll be using this value 185539.33 will be equal to 9.55 into 10 to the power of 6 multiplied by capital N. Capital N is how much he has given. Okay, we need to find capital N, speed, certificate. So you got this value of N. N how much?
14.57.
14.57 kilowatts. 14.57 kilowatts. We got the value of capital N. Now, is the problem completed?
No, sir. Need to
Yes.
find axial force.
Yeah, yes. Required axial force once again. So, required axial force. Required axial force. Once again, when I'm trying to go for required axial force, I'll go for this equation. Same equation. MT is equal to half mu FA dm I. So here implies 185539.33 half mu is how much? 0.1. I think you'll have the same answer, I believe. FA, you don't get different answer. FA, because I is not changing here. Okay. FA multiplied by dm is how much? We have got 166 into 8. So FA, I think FA should be the same, right? No other option. No other option. FA will be the same. See, I told you, this is the only option which you have got. Required. In this case, see, in this case, both the values are same. There is a reason for this. What happens in this case? Since why I am getting a change in this value of FA is because of I. But this fellow in this numerical itself, he has given the value of I. Now try to check these answers. This value and this value will be the same. Both the values are same because this I became constant. This I became constant because initially what we are doing in this case, especially I, we used to get some 7.6. We try to make it up 8. So our 6.85, we try to round it up to highest number. That is one of the reason which we are trying to feel that FA is being changed. Now try to see this both equations. This equation and this equation. These two equations are one and the same. This equation and this equation are one and the same. So obviously FA should be the same value. You don't get the different value of FA. So you have got this required axial force. This itself, what you have found, the maximum itself is required. The maximum itself is required axial force here. The reason this value of I is not changing. So what you do is you don't get worried in the external examinations. If you have any confusion, you try to solve once again the same, and you will end up with the same answer. That is not an issue there. So this is your required axial force. Any questions, guys? Any questions on this? So listen, guys. I'll try to do is I'll make a brief overview, very quick overview. Then we'll stop the session now. Okay, what we have done till now. Very quickly, I'll recap. Parts of the clutch we have studied. Okay, what are the different parts of the clutch? How the clutch happens? And main important thing in the clutch is the friction plate. Main important thing in the clutch is friction plate. This is the most important. Now, how it works, we have already seen. Most important, diaphragm spring. Now, here try to understand the different parts of the clutch. Now, here D1 is diameter, inner diameter, D2 outer diameter, and H is the thickness. By default, H will be 1 to 3 mm. And if it comes, he gives in terms of radius R1 and R2, and this is called as the radial width. Remember this, the term. Sometimes that fellow uses B as radial width, so he'll be using this. Now once we are done with notations, and remember this is the nothing but your DM. This orange color circle which I'm trying to show is dm. On this dm, the frictional force F, FF will be acting. This is the value. FF will be acting on the dm. That is the reason we call this mean diameter, where the frictional force will be acting. So this is the values, and these are the notations which we use. And two theories which we always work: uniform pressure theory, uniform wear theory. Now here always in case of uniform wear theory, the pressure maximum pressure will be at the inner radius. This is the reason why you remember this. We have an equation pi p d1. D1 is coming because it is at the inner diameter. Okay, so you remember pi p d1 into d2 minus d1. So why d1 is coming? Because of this, there is pressure is maximum at inner diameter during the derivation. And torque we have the torque once again here. All the equations which we use, these are the only equations which we have used. Now the other points, important points for numericals, and this is the most important table number 19.7. Table number 19.7, and we start with the questions. We have started with many questions. Question number 1, 2, and how do we use the tables? So especially when I'm using this table, you can understand that we are using for dry friction. Means it is single plate clutch, which I was trying to solve it. Now we have solved 5 problems. Okay, in case of single plate clutch, I have given question number 5 as assignment. Hope you have done it. Okay. Now I'll be giving the other questions also. Now we shifted to multi-plate clutch. So multi-plate clutch has a series of clutches. Once we have a friction linings, this is a friction lining and this is a steel shaft. The friction linings will be on the shaft, driving shaft, and this one will be on the hub, on the top. It will be moving. So both the things together we call this as shaft itself. Okay, and we have seen the working principle. We have seen the working principles of this, both the clutches. So this is what the working principle we have seen with the videos. How exactly the multi-plate clutch will come during the disengagement, what exactly happens, and when it is engaged, what exactly happens. So engaged, even including the hub, entire shaft will rotate. So disengagement and engagement is must be more clear for you. Okay. Once it is done, these are the important points to remember which we have discussed in today's class. Materials to be selected, keyway factor, which value of D1 and which value of D2 has to be selected for you. Then what happens if there are a range of speeds has been given, which speed has to be selected, and the coefficient of friction is which table, 19.7, which table to be used. Okay, if for dry friction, for single plate clutch, dry friction, multi-plate clutch, wet friction, and average value of mu and p, you should take it, and always use uniform wear theory. And other points to remember: if no friction material has been given, leather, you select leather as a friction material. And single plate clutch will be having a value of I is equal to multi-plate clutch. I is always greater than 2. Now in multi-plate clutches, what exactly you are supposed to do? What are the different things which you are supposed to do? I1 by 2, all the things. Now here other points to remember: use these equations to find D1 and D2. Most important equations. Remember guys, 9191, 9190. If you have any doubts at any point of time, please ask me. Then the other formulas. How do I find the maximum or limiting pressures? So use this from back. These are the values. So actual pressure or limiting pressures you will find using this formula. And most important thing is the average pressure is. Thus most of the times he has asked in many questions the average pressure, mean or average pressure. So if you want to find mean or average pressure, find FA. Through this formula you need to find. Only the change which you need to use is DM. So DM you use it, and this FA also has to be found using this equation. FA has to be found using this equation. Once you are done, so all these process we have solved. Now here, see, try to understand. I have used wet friction. In this case, I have used wet friction. And once again, guys, I forgot. The students who has worked in question number 6. Question number 6, to find this mean unit pressure. Mean unit pressure. What we have done is we have used D1. And when we are solving this, we have used D1, especially question number 6. We have used D1. It should be not D1. It should be DM. Remember this. While calculating FA, we have used D1. Kindly go back to question number 6. I repeat, go back to question number 6. Kindly change it to DM. It is not D1. It is DM, which you are going to change it. Now come back question number 7. We have solved all the questions are from your previous papers, guys. Question number 7 we have solved. Question number 8, 9, 10 and 11. What I'll be trying to do for you guys, see, let me. I'll be sharing these questions to you. Try to see this entire questions when they have given for which marks. Hope, are you able to see my screen word file?
Yes, sir.
Now see this question, man. Very bad. Sometimes this is what happens. Question number 2. You see, observe question number 2. See the marks of question number 2. The marks of question number 2 is
4.
4 marks, guys. 4 marks. Sometimes this was sometimes we cannot help. We cannot help. 4 marks he has given. The other question he has given for remaining marks, but 4 marks also he has given. This what exactly you are finding? You are trying to find the outside diameter of the clutch. So I have typed all the questions for you, and all the questions 13 questions. There are many more questions actually. 13 questions. For the other questions we have, which we will be trying to solve. And most important thing is try to see here now. The FA which you are going to find here. Always see every numerical you have found FA, right? This FA, there is a link from here to springs problems. Remember this. Next, when we are starting module 1 in springs, the question comes in springs something like this. What happens is there is a springs are attached to the clutch. Find the dimensions of the springs. Now, in such cases, first we need to find FA using clutches. What is the force required to activate the springs? You remember the diaphragm spring. The diaphragm spring has got a name, belly-willy spring. When the diaphragm spring is also called as belly-willy spring. Okay. Now, sometimes compression springs are used. Now, how do I calculate the dimension of the spring? By using this value of FA from the clutch. So always remember this. Since it is transmission system, everywhere links has been given. So FA will be used. We'll be trying to use this FA in springs. Okay. We'll try to use FA in springs. So this is what exactly we'll be trying to do. So any other questions you can ask me now.